June 30th, 1908, a remote region of Siberia. The morning was calm. Then witnesses reported something extraordinary. A blinding object streaking across the sky, traveling at nearly 27 kilometers per second, faster than any bullet ever fired. Then, at an altitude of several kilometers, it exploded. The energy released was estimated between 10 and 15 megatons of TNT. The blast was felt hundreds of kilometers away. In parts of Europe, the night sky glowed for hours. People could read newspapers at midnight without artificial light. Nearly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. Over 2,000 square kilometers of forest were flattened, an estimated 80 million trees destroyed. But when scientists arrived, they found no crater. The explosion occurred in one of the most remote regions on Earth, central Siberia. In 1908, there were no roads, no railways, no nearby cities. Political turmoil and the coming Russian Revolution delayed any serious investigation for nearly 2 decades. In 1927, scientist Leonid Kulik led the first expedition to the blast site. What he found was extraordinary. Trees were flattened in a perfect radial pattern, all pointing away from a central location. But at the center, something unusual appeared. Trees were still standing, stripped of branches like telegraph poles. There were no large fragments, no impact crater, no obvious meteorite debris. The object had exploded in the air. When an asteroid enters Earth's atmosphere at nearly 27 kilometers per second, air cannot move out of the way fast enough. A shock front forms in front of the object. Air pressure builds rapidly. At extreme velocity, that pressure becomes greater than the asteroid's structural strength. It shatters. Instead of striking the ground, it explodes in the sky. This is called an airburst. The energy expands outward in all directions, but also downward. The downward blast explains why trees at the center remain standing. They were stripped clean, but not knocked over. Tunguska released up to 15 megatons of energy. The Hiroshima bomb was about 15 kilotons. That means Tunguska was nearly 1,000 times stronger. Yet, because it exploded high above ground, it left no crater, only a scar in the forest. Some scientists proposed a different explanation. What if it wasn't an asteroid, but a comet fragment? A comet is mostly ice. If it exploded midair, it could vaporize completely, leaving little trace behind. In 2007, researchers suggested that nearby Lake Cheko might be the impact crater. A fragment could have survived, striking the ground. But sediment analysis suggested the lake may be much older than the 1908 explosion. More exotic ideas followed. A miniature black hole, a hidden volcanic eruption, even an alien spacecraft. But no radiation anomalies were found. No gravitational disturbances, no physical evidence of advanced technology. The data does not support these claims. The Airburst theory remains the most consistent explanation. On February 15, 2013, another object entered Earth's atmosphere over the Russian city of Chelyabinsk. The explosion injured over 1,500 people. It released about 500 kilotons of energy. Tunguska was at least 20 times more powerful, and Chelyabinsk was only about 20 meters wide. If Tunguska had exploded over a populated city, the devastation would have been catastrophic. Today, astronomers track thousands of near-Earth objects. Many pass safely. Some are still being discovered. Objects as small as 30 to 60 meters can cause regional devastation. Tunguska was a warning. The forest has grown back, but the threat has not disappeared. Objects the size of Tunguska strike Earth roughly once every few hundred years. Larger ones are rarer, but smaller ones are common. Earth is constantly bombarded by space debris. Most burn harmlessly in the atmosphere, but modeling shows that mid-air explosions like Tunguska remain statistically inevitable. Today, planetary defense programs monitor thousands of near-Earth objects, but not all are detected early. Objects approaching from the direction of the Sun are especially difficult to detect. In 2022, NASA successfully altered the orbit of an asteroid. For the first time in history, Tunguska was not the end of the world. It was a warning. The sky above us is vast, and sometimes unpredictable. The question is not if it will happen again, but when.